Hello, ladies and gentlemen. I would like to welcome you back to studying the periodic chart. And we have been studying specifically the structures of the periodic chart, going through the different regions and groups of the periodic chart. Today we are going to finish the last two groups of the periodic chart, and we're going to start with the halogens. You can see that they are from group 7A. This makes them extremely reactive because remember the valence level is full at 8. So all it wants is one more electron. So that makes it very, very reactive trying to get that one electron. The name halogen just means basically a salt former, so that you have a salt formed when the halogen gas bonds with a metal. You're familiar with chlorine and sodium, making sodium chloride or table salt. There are lots of different types of salts, but that is one of the types. Okay? Halogens, let's see. The first one we're going to talk about is fluorine. You're used to fluoride being in your toothpaste. Some of you probably have fluoride in your water, although there is controversy as to whether fluoride in the water is healthy or not, so some communities don't do that anymore. I really like this video. I think it's cool. I'd rather do it in person, but I don't have the toys. This is what they're going to do is all they're going to take is fluorine gas and let it flow over the brick. The kind of roar that you hear in the background is actually a ventilation system so that the person doesn't have toxic fumes from this going on. But I'll just let you see. It's pretty cool. Okay, so it's just flowing over the surface. There's no fire or heat involved. It's just that reactive. Okay, you can see there's no fire coming out of the torch. It is literally just a gas. And you can see that the fluorine just literally burnt away the corner of the brick. And that's just from a reaction with the gas. Okay, there was no fire involved. Just the gas flowing over, which caused fire to happen. Okay, hold on. Okay, on to the next. Sorry for the technical issues. Okay, chlorine you're probably more familiar with. It is something that is widely used in lots of areas. Chlorine, as we've talked about already, in table salt. You're familiar with it in things like bleach. It is a chlorine solution. What you might not be aware of is chlorine is also added to your drinking water to kill different germs and things. You put it in your pool for the same reason. However, it is also used to make PVC, which you can see the pipes that are up here, lots of plumbing and things done with PVC. It is used to make cloth and thread and things like that, especially different dyeing processes. This is paper that is made using chlorine. And the picture at the bottom right, unfortunately, is where chlorine is being used as a toxic gas. If you've ever heard of using gas warfare, this was what happened in World War I. And they would use chlorine gas as well as other types of things. And it is toxic and it ends up killing people. So unfortunately, chlorine has been used for that as well. Okay, bromine. There's not too many uses for it anymore because it is relatively toxic. As you can tell by the person wearing the mask that's spraying it, it is used as an insecticide. And the coats below are actually for firemen if you don't recognize them. And bromine is also something that's embedded into clothing in order to make a flame retardant so that they don't burn. So things like the firemen's jackets, children's pajamas, certain fabrics and things that are in your home would be treated with compounds including bromine so that they are less likely to burn or burn quickly. Iodine is often added to table salt. That is because it is a needed nutrient that we generally get from seafood. And most people don't have a regular access to seafood. You can see the scan up at the top right. Generally, the iodine in this case would be used as a contrast. You can see the lines in the picture, and those are using iodine to show the contrast. Iodine also for many, many years has been used as an antiseptic. So it would be put onto cuts and scrapes. It's used before surgery to clean areas. If you've ever had surgery, you may notice you come out with this yellow stuff or brownish looking stuff around wherever the incision was. That is iodine that is used to sterilize. Okay, group 8 are the noble gases. They are referred to as noble gases because they have all of their valence electrons, so they are completely and totally non-reactive. They don't want any more electrons. They don't want to get rid of any electrons. They are completely happy and content as they are. So they are noble. They're kind of separate from everybody else. Okay, think of like the nobility in the past. Okay, because they're not reactive, or very few are reactive under normal circumstances, you have ones that primarily are used for lights of different types. When you think of neon lights, that orange color is actually the only real neon light. All the other different colors of lights are actually different types of noble gases. And they have the different names there. So you have helium, giving that kind of pinkish color, pinkish purplish color. Neon with the classic orange. Argon with the blue. Krypton always makes a nice bright white light. And xenon is kind of a bluish white light. And these lights are used for lots of different things, including lasers and bright lights needed for safety and things like that, besides just lights to make signs that look cool. Okay, next I want to show you a video. A lot of people are aware of what helium is. It's a semi-regular substance in our lives. However, there might be some things about helium that you aren't really aware of. Okay, when the video loads, here we go.
Squeaky voices and floating balloons are what most of us associate with the gas helium. But in fact, the depleting natural resource is essential in medicine and technology, like MRI scanners in hospitals and the production of fibre optic cables. So predictions that reserves will run out by 2020
didn't
could have
happen.
repercussions far greater than initially thought. John Saunders is Professor of Physics at Royal Holloway University.
Liquid helium is essential to cool the superconducting magnets that are used in MRI scanners. So that means that the availability of liquid helium is critical to ensuring that MRI continues to be available to patients.
Concerns over helium supplies have been raised in a report published by the National Research Council. The study proposes urgent changes to US government policy. With the rise in emerging economies such as India and China, world demand for helium is also increasing. Helium-4 is extremely rare. The only source is natural gas, which we extract from the earth for fuel. To access helium, this gas has to be liquefied and refined. The United States produces around 3/4 of all helium and uses around half of this. Most of it is stored underground in Texas and neighbouring states. Central to the argument over helium is how this stockpile is being used. Under federal law passed in 1996, helium is being sold from the Texan store at knockdown prices to US government agencies. Because the gas is so cheap, it is not economical for companies to recycle it. The NRC suggests that helium stockpiles in Texas should become a last resort, and the world should look to developing reserves in Qatar, Algeria, and Russia. But Professor Saunders says the answer is also to recycle the gas.
The NRC's projection of future demand are that supply should meet demand until about 2020. What should happen and can happen to dramatically improve the situation is that all users of helium should be recycling that helium, just as we do here in this laboratory.
NASA and the Department of Defense use 25% of the US's helium to clean rockets and to get rid of explosive fuel, but they don't reuse any of the fuel. Experts suggest that the price of helium will need to rise dramatically. This will send the cost of a party balloon through the roof, but bigger consumers like NASA might be persuaded to start recycling it. Kira Sutton, Reuters.
Okay, and if you're wondering why there tends to be a shortage, or at least they're predicting a shortage, this actually has to do with the properties of helium. Helium is, as they said, mined from underground, and when you pop that balloon or you suck it out and make your squeaky voice, that helium is so light that it actually will leave the atmosphere, and we don't make more. So all the helium that is on the Earth is what there is. So they are concerned, since certain technologies are depending on the use of helium, that someday, if they stay dependent on it, that we're going to run out. Obviously, we haven't run out by 2020, but the question is have they started changing the procedures, or is it that they actually have more than what they realized? But whatever the case is whenever we run out, we no longer get helium balloons at our birthday parties. And I'm guessing that's probably going to stop before we run out. So I will answer any questions you have. Remember, you have an upcoming test.